Hello,
Hi, Praveen.
Santosh. Hi, Santosh. Good morning. How are you?
Yeah, doing good.
Okay. Okay. We'll wait for Sukanya and Nikhil.
Okay. Praveen, I am not able to see your share screen alone. Have you shared?
I will share in 2 minutes. Just wait a second.
Okay.
Hello, Nikhil.
Praveen, Nikhil. Praveen,
Yeah.
Nikhil.
Yeah, cool. So we are waiting for Sukanya. I don't know if she has joined some other meeting. This is wrong. Yes. So everyone is here. Let's start. Okay. We'll begin now. Just a minute. I'm sharing the slide first. Can you see the slide?
Yes.
Okay. So before we begin with this slide, we'll just try to talk about the previous questions and previous lecture and assignments which I gave. Okay. So let me begin with the. So in the last class, we learned about we did few questions on arrays and strings and a little bit about Boolean methods. Okay. So what was the question in the Suganya? What was the question? The solution you gave, the ID1 solution you gave submitted.
I submitted the answer for that birthday invitation.
Okay. So you have to, like, the question was to find the whom you can invite, the smallest person whom you can invite, the least experienced person, and in simple term, you wanted to find the minimum smallest element which is missing. That was the question. Simplest question in simple terms. Find the minimum or the smallest number which is missing. Okay.
Yes.
Yeah. Others, I don't remember if you submitted or not. Did you try this question?
Yes, I submitted.
Okay. Let me just find your solution as well. Okay, so we are going through the solution which was submitted by Nikhil. Okay, So what he has done, Nikhil, can you do it? Can you explain yourself? Then we'll discuss.
Pardon, Praveen, I didn't get you.
Can you see your code? The submission.
Yeah. Hello. I can't hear you guys.
Can you hear me?
Yeah, now I can hear you.
Yeah. So, Sukanya and Santosh, can you hear me clearly?
Yes.
Yeah. Okay. So, Nikhil, just try to explain your solution in like 2 minutes, and then we'll go ahead.
Yeah, mine is like simple. So what it does is it checks whether 0 or not is there, and otherwise it prints 0. Otherwise it iterates the entire array with respect to its length -1, and then it checks the difference between the ith plus 1 element and the previous element. Otherwise, if the difference is greater than 1, it prints the next element.
Okay. So others, did you get his solution? The simple thing he's trying to do is he's just iterating one by one and checking if the element which should be present at that position is it present or not. So how he's checking that? He's just checking the difference, the current element is just one smaller than the next element. If not, then means there is some number missing over there, and that's what we have to find. So what we have to find is the minimum missing number. Okay. The question was find the minimum, the smallest missing number, and we also had this thing given. This array contains all the numbers in sorted order. Okay, the elements contain all the numbers in sorted order. So if everyone remember the question was the birthday's question, Sukanya's birthday question, all those. So that question was a word problem. We have reduced to simple this to simple question, which is find the minimum element in a sorted array. That's it. That was the question was. The whole big question, the whole big story was for nothing. It was just for you to draw and make it simple. Just find the minimum or the smallest number which is missing in the array, and the array is already sorted. And also it contains numbers, like it contains all the numbers from 0 to n -1. That is given. So smallest missing, what he's doing is just iterating one by one. Okay, is the first element 0 or not? No, it is not. So if it is not, then if it is not 0, then that means 0 is missing. Then he'll check next element. Is it the index and the value is same or not? If not, then he'll move to the next element. So you're just checking is the element, because since we know it is already sorted order, and since we also know that all experienced guys are there, this means all the numbers are there. All the numbers are from 0 to n only. So each index will have its own number. So we simply have to go through each element and just check if that is present or not. 0 index has 0 or not. 1 index has 1 or not, or 2 index has 2 or not. And after some time, we'll find a place where this number is not present, and that is a place which is missing. As simple as that. So simple iterate and just find the number. The complexity of this solution is order of n, and we wanted to improve upon that. Both of your solution and Sukanya, I think your solution as well is your solution also is order n, I guess.
Yeah. Yes.
Okay. So if you think it a little bit otherwise, I mean, in slightly different way, this problem, finding the minimum missing number, is it not same as finding the number?
I didn't get you.
So let's talk about a different question. Given a sorted array, find a number. Given a sorted array, find a number. Like where is that present in the array? You have to find that. Like find an element in an array, sorted array. Have you heard this simple question? Find a number, find an element in a sorted array. How do you do that? So question is a very simple question.
We have
Yes.
to find it whether it is before the middle of the array, or we have to first find out the mid value of the array.
Yes. So the solution you're giving is we'll do a binary search. We will not do a linear search. We know since this is a sorted array, we should take the advantage of that fact. This is a sorted array. So we will try to do a binary search and not a normal search. Okay, that's what we do in a finding an element in array, in a sorted array.
Okay. Got it. Yeah.
So this question is almost similar. Okay, we are trying to find something missing, and we know this is sorted. So this must be. We'll try to jump at the middle, and we'll try to check if there is number any missing, if the number missing over there or not. So since this is sorted array, we know that at ith index the value should be I only. If it is not I, this means I is missing. So if it is bigger than I, if it is less than I, depending upon that, we'll go on that side. So suppose we jump at the middle, and this number which we're trying to so middle element is suppose more than its index. Okay, if the middle element is more than its index, this means some number, the number missing number will be on the left side. Do you get that? If the middle number is more than the index. No? This line you didn't get?
Didn't get it, Praveen.
Okay, let me just write something then. So what is the middle element here? 5?
Yes.
So what we do, we are trying to find the minimum number which is missing. Okay, minimum number which is missing. And we jump to the middle element and we checked whether this number is more than index or less than index. Index is, right now, what is the index? Index will be, so we are starting with start and end. Start is equals to 0 and end is equals to 8. And mid is equal to start plus end by 2. Now, we know that A of mid is equals to 5 and mid is equals to 4. So we just check the element at 4th index. What is that? Is it 4 or is it less than 4 or more than 4? So if it is, suppose I'll take two cases. One, when 0, 1, 2, 3, 4, 5, 6, 8, 9. Okay. So there are two cases. One case when A of 4 is equal to 4. This means when A of 4 is equal to 4, this means there is no number missing on the left side. This means the number would be missing on the right side only. Okay. Either or in the second case, when A of mid and A of 4 is not equal to 4, is equal to 5, this means the missing number would be on the left side. So there are three cases, not two only. Either, let me do so this is how the code also will be for these three cases only. 1, 2, 3, 4, and 5, and 6, and 7, 0, 1, 2, 3. Yeah. So the three cases, we jumped into the middle. Okay, we jumped into the middle and we first check. So this is middle element, and so let me write the code as well now for you. So we have the middle. If A of mid is the missing element, else if A of mid is equal to mid, else A of mid, A of mid is more than mid. So there are three cases possible. Every time we jump to the middle element, there are three cases possible. Okay, first case is we know we have found the middle element. How do we know this is the middle? This is the element which is missing. So we have to check if the A of mid plus 1 is 2 more than A of mid. This is this thing which I have written. If A of mid plus 1 is the missing element, how do we check this? This is equal to if A of mid plus 1 is more than A of mid plus 1. Sorry. Yeah. So what this is if the next element, the moment the place where we landed, and if the next element is 2 more than the current element, this means this number missing between 4 and 5, mid and mid plus 1. So this is where here we return A of mid plus 1. This is the missing element. Understood? This is what this is. I have written in English as well as code. So is the
Praveen,
yeah?
I didn't get the A of mid plus 1 is greater than A of mid plus 1.
Praveen, that's a condition never satisfies, no?
No, why not? So in this case, we landed at 4th index, which is this. Okay, A of, so we are talking about the first array, A of 1, array 1, array 2, and array 3. Let's talk about, so now we are talking about array 1. Okay, so array 1, mid is equals to 4. We are talking about array 1. A of mid is 4 and mid is, okay, we are talking about array 1. Do you see this happening? Wait. Yeah. So in array 1, which is this, start equal to 0, end equal to 8, mid is equals to 4, A of mid equal to 4. Now I'm checking A of mid plus 1, which is A of 5, and here A of 5 is, what is A of mid plus 1? 6. Okay. So what is here? A of 5, 6, and A of mid, which is 4 plus 1, 5. So this is 5, and this is greater than 5. So what I'm trying to say is, if the next element of the mid is just not the next element, 6 is, so middle element is 4, and next element is not 5. Next element is not 5, next element is 6. So this means there's some number missing between 4 and 6. That's it. That's what it means. If the next, what is, let me write for you again then. What is A mid here? A mid is 4, and A of mid plus 1 is 6, isn't it? यही है ना? तो यहाँ पे when A of mid is equal to 4 and A of mid plus 1 is equal to 6, it's not equal to 5. A of mid plus 1 is not equal to 5. This means that there is some number missing. That's what I've written here. If A of mid plus 1, okay, let me write a simple way also, is not equal to A of mid plus 1. The middle element plus 1 is not just the next higher element. There's some number missing between A of mid and A of mid plus 1. That's what it means. Abhi bhi samajh nahi aaya? Shall I try some other way?
Yeah, got it.
Okay, let me repeat once again. So what we're trying to do, we are trying to find the next missing element. Okay, next missing element will be at least, if not the full array. Suppose I know. Suppose let's take a case where I know that there's some number bigger than 4 only which is missing. Okay, suppose I know the number which is missing is bigger than 4. Then it's easy now. Okay, next element is 6, and the number missing is bigger than 4. Then obviously it is 5. It must be between 4 and 6. Now coming back to this, what I'm trying to say is we are trying to check one by one. Okay, every time we land to an index, we landed to an index means mid is equals to start plus end by 2. We landed to that index and checked. Okay, now I've reached a point. Is that element missing? or the next element missing or previous element missing, we have to decide that the number we have, the place where we landed, is the number missing or there only, or is the number missing on the left side of the array, or the number missing on the right side of the array? How will we check whether the number missing is somewhere there only? So three things can happen. The index where you landed, the next element is missing. So we landed here on the 4. Okay, we landed on the mid element, which is 4 only. And we know कि we're just checking कि क्या 5 है कि नहीं है. The next element is 5 or not. That's simple check we are trying to do. Is the next element, if not equal to, so what we did is we just check is the next element one greater than me or not. If not, 5 is missing. That's simple check we're doing. I am 4. Is the next element 5 or not? That's simple check I'm doing. If next element is not 5, this means 5 is missing. ठीक है, समझ में आ गया ये लाइन?
Yeah.
So that the moment we see, the first time we land, because only we have to find the minimum element which is missing, and since all the numbers are present, since all of them are sorted, the first number we find is the minimum missing element, because at fourth index 4 is there. This means on the left side all elements would have been present. That's why the fourth index has 4. If any number would have been missing, the fourth index would have some other element. It would not have contained 4, because अगर suppose 2 missing होता तो 2 की जगह पे 3 होता और 3 की जगह पे 4 होता, तो 4 की जगह पे कुछ और ही होता. Okay, so the moment we landed, that was 4. We checked. Okay, we do not check, by the way. We just told. So let's check for the first. If a of mid is equal, I'm just writing some unnecessary conditions for you to understand. These things are not needed. If a of mid is equal to mid, and a of mid plus 1 is not equal to a of mid plus 1. So this means the place I landed has the element which should be there, and the next element is something else, which is not 5, it's not mid plus 1. So it means mid plus 1 is missing. Okay. Now after that, what I checked कि चलो ठीक है, next number is the element which is there, but the next element is not, it's just 5 only. So it means 5 is not missing. So let's now go ahead and check is the current element equal to mid? Is a of mid equal to mid? So it says yes, it is equal. So this means the number is missing on the right side. So we call the method recursively on mid से लेके end तक, on the right side of the array. Do you get this now? So what I'm trying to say, this is for the case, this one, A2. Let's see about the A2. So what I just landed and I checked A of 4 is equal to 4. This means the missing element would be on the right side. It won't be on the left side, because from 0 to 4, all the numbers are present. That's why the index is, at index 4, we have 4. Otherwise, at index 4, something else would have been there. But no, we know the
Praveen,
yes.
Shouldn't it be return a of mid plus 1 comma end?
Comma?
Instead of mid in the return, when you're calling it recursively down, it should be mid plus 1, right?
Yes. Again, I don't talk about edge cases right then, but yes, you're right. Okay, you're right. So are you clear about why these 3 lines? The most thing you have to see, the important thing is these lines: if, else if, and else. Okay, important thing. So we're doing simple landing to index, checking if that is the place where we have found our minimum missing element, or should I go on the left side, or should I go on the right side? That's simple call we are taking. So first call, is this the place where I'll find my missing element? Is like go and check the next element. Is the next element just 1 bigger than me or not? If not, if the next element is just not 1 bigger than me, this means that next element is missing. A of mid plus 1 missing. If it is not, if it is equal to just 1, if it is just 1 higher, then it means then the number is not missing. So we have to decide. Now we have to decide is the current value is equal to index? Yes, it is equal to. This means the number is missing on the right side of the array. So I'll call recursively on the right side of the array. I'll call the method recursively a mid plus 1 comma end. Otherwise, I'll call recursively on the same method on the left side of the array. start mid or mid minus whatever. Okay. Okay. So अगर कुछ इशू है कुछ क्वेश्चन है बताओ. I'll move ahead after this. Santosh?
Got it. Yeah, got it.
Got it? So the fact we used is sorted. Always keep things in. The moment you see sorted array and you have to find something missing or not missing, you have to do some search and there's some sorted order present. So keep in mind the mostly solution would be in order log n only. If something is already sorted and you have to find, the solution is going to be somewhere around order log n. Don't be satisfied with order of n. Okay? Because
Okay.
order of n, if you're doing a sorted, then you can do that in even unsorted as well. Because what is linear is check all the elements one by one. So what is the use of having it sorted? So the moment you see something sorted, just your mind should click. I should be getting something order log n. Okay.
Okay. If array is duplicated, then
What do you mean duplicate? The same question.
yeah, if the array is sorted plus duplicate values also there, then in that case also binary search would work.
We'll have to think. Let's think. I'm not sure. So you're saying this array sorted, but we have duplicate element. In that case, your simple search will work for sure. But will the minimum missing element work? I do not think that will be so easy. We'll have to think. If you want, I can think later. But if it's just finding element in a sorted array, order of log and binary set will work perfectly. But finding the minimum element will not work. Everything. So if the array is not sorted but duplicate element, I cannot guarantee. No. So we cannot do that.
Okay.
That's why I had in the question I had already mentioned all the people who are coming into the party have different experience. So it was already mentioned, and this was her question as well. Sukanya's question as well. So this is a special question and a special solution. Okay. Cool.
Yeah.
Nice. So I'll share the slide once again. Okay. So we'll have more questions from our string and array and a little bit of Boolean. We'll do more of that, but not right now. We'll go ahead with the next topic. So I could have tried to go deeper into array and string and all, but I think let's complete things and then we'll have questions when we know everything. Otherwise, just when we know that this question is from a string, it is easy to solve. But when it comes to you can use anything. That's the real test. Okay, so we'll do both the things. One, when we are learning the topic, at that point of time we'll do some questions. But once we have done all the topic, then we'll do more questions so that you have this thing in your mind. We can use anything. Okay. Moving ahead, stacks.
Praveen,
Yes.
Like what about multi-dimensional arrays? We didn't go through that.
Multi-dimensional arrays is one thing. Yes. What is the other thing?
No, I mean we didn't solve any question on that.
Okay. Okay then. So let's do one question then on multi-dimensional array also. Of course, that is also needed.
And one more thing, can you kindly help with rotated array also? I have no idea about that. That's why I couldn't solve the second question.
What rotated array?
Yes.
So see, these are not data structures as such. These are spatial data. Rotated array is not a spatial data structure. It's just an array as only. These are different variations of the question. Even 2D array, is a different variation of the question. We might call it a data structure as well. So we'll do one question on the 2D array, but the rotated thing is a variation of the question. We'll have to do more question on the rotated array. So there's no special theory regarding that. We can do few questions. So did we do that question finding an element in a rotated array?
No, I couldn't solve it.
Okay, you cannot solve it. So let's solve that question also, and we'll also solve take one question on the 2D array. Again, there is no special theory behind any of those, but we'll try to do two questions. So that's not a problem. The new way I'm trying to do is, the one more thing I'm trying to do is, before every class, there are two kinds of classes. One is mostly about theories, and the other is about the questions. So in the questions classes, mostly what I'll do is, I'll bring around 4 to 5 or 6, 7 questions, and we'll try to solve all those questions possible. Whatever is possible, rest you'll take home. So all those 6 questions will be, or 7 questions, 8 questions, whatever, will be visible to you in the beginning of the class. I have to prepare for the class every time. So this is what I'll do, and we will try to solve few questions in the beginning in the class, and rest questions you'll take home. Apart from that, the theory class like this, what I wanted to start today, the stacks. So that is other type of class, in which mostly I'll cover the slides along with one question per slide or per something, and that's how we'll do. So okay, let me do 2 more questions. One question on the rotated kind of array, another question on the 2D array. Okay. So the thing is, I have taught for a longer time. What I've seen is we spend a lot of time in the easier data structure, but I wanted to do it like we should be giving more time to our complex data structures, which we haven't gone.
Praveen, then you can give us those questions for homework, and we can go with stacks now. Maybe I'm not sure. I think.
Okay. So Sukanya, the question. Let's do that question only, and for 2D, I'll give one question for assignment, and then we'll discuss over the week and also in the next class. Okay? The 2D thing. There is no special theory about that. You can just simply access any element by A of I and A of J. So A of ij. That's the way to understand that. The rest is like understanding how to loop onto a 2D array and all those things for I equal to 0 to n and for I equal to 0 to m. So each element you can access A of ij. Simple as that. That is what 2D array as theory is. There's no special theory regarding that. There are special questions, of course. There are lots of questions in 2D array, but I don't see any special theory behind that. And since all of you are engineering, you must have used array a lot, and accessing an element in the array, 2D array, is not a big thing. Finding element is just scanning one by each index, like A of 0, 1, 0, 2, 0, 3, 0, n, 1, 1, 1, 1, 2, 1, 3, 1, 1, n, and 2, 1, like that. That is what 2D array is. So I'll take one question for sure. We should take a question because you find a lot of questions on that in interviews. So we'll take few questions. One question I can ask right now. We can discuss and we can do solution later. Okay. So the question, let me first start with the Sukanya's question. Then we'll come to this question, 2D array question. Sukanya question, your question was, or like the rotated array question, which I gave or not, I don't remember. But the question was, find an element in a sorted and rotated array. This was the question?
Yes.
Yeah. So the array is sorted as well as rotated. What does rotated means? I'll go back to my this editor. Just a second. So we have our sorted array. And we now rotate this. Let's try to rotate this.
Praveen, when you mean rotate, it can be around any element, right? Along any index. So
yes. Let's do only one rotation. Just one rotation, which means single rotation. 2, 3, 4, 5, 6, 7, 8, 9, and 1. This is single rotation anti-clockwise. Okay. And this is this array is like rotated 4 times. 1, 2, 3, 4 went at the back, and the rest came at the front. This is what rotation means. Okay.
Okay, got it.
Yeah. So this is what sorted and rotated array. We have to find some number. We find where 7 is. Find where 3 is, something like that. So finding a number in a rotated and sorted array. Anyone did anyone try this solution? And what was the best you could achieve this time complexity?
I did not get time to try.
Binary search in the same way we can try. the log n complexity. And another one is linear search and O of n we can do.
Come again, I didn't get you. Binary search, what was that?
Binary search with the log n complexity.
Okay, so you're saying you'll do binary search.
But how will we do binary search? It is not shorted, no, once it is in a rotated form.
Yes, you're slightly right. Then, Santosh, can you tell how will you do now?
Yeah, we can take start index and end index, and we can get the middle element of that.
Yes.
Then middle element, suppose there, 2, 3, 4. Suppose the 4 index is the middle element. Okay, there are cases like we can take the middle element plus next element is greater than or less than 1.
Next element is?
Greater than of the mid element or not.
Okay.
If it is not greater than, then fifth index position is the sorted one. So 1 is the minimum element, from that we can return that.
No, we are not finding middle element. We're finding any element.
No, first we can find the middle element, and next case means next condition is A of mid is less than A of mid plus 1.
Is less than A of mid plus 1. Then what?
Then we can return A of mid plus 1 is the minimum element from the rotated array.
No, we're not finding the minimum element. Minimum element. We want to find the we just want to find element. There's no minimum. Find element.
Okay.
Like find. Sorry. It's like find 4. Where 4 is? That's it. Find the index of 4. That's it. Okay. Even minimum we also will try to do, but this is a simple question. Minimum will be a little bit trickier, but this is simple. Find the element. That's it. Where is that present or not? So do you think binary search will work here? So if it was simple array, if it's simple sorted array, then everyone can do in binary search. Okay, since it is sorted, I have to find 4. I'll jump to the middle element. Is the middle element is equal to 4 or not? No. So is it bigger than 4 or less than 4? If it is bigger than 4, then this means 4 would be on the left side. If it is less than 4, then this means 4 would be on the right side, and we'll do recursively on the that part of the array. But since this is not simply sorted, it's sorted but a little bit rotated as well. So the problem with this is, what is the problem with binary search here is, we check, we landed the middle element, we see that this element is equal or not. If it is equal, we found the element. If it is not equal, we cannot simply say by comparing, is it bigger or less than, is it greater than or less than equal to the element, middle element. We cannot simply say go to the right, left, right. It's a little bit trickier here. Do you get the problem with the binary search here?
Yes, I got.
Yeah. So how will you decide whether to go on the left side or the right side? If we have to do binary only, suppose we have to, I give you the hint. Yes, we have to use a binary search approach only, but the simple. Yes.
Is it in 2 division we have to do binary search? These 2 parts.
What? Come again, Suganya?
Do we need to do binary search in 2 parts? Means first on 5, 6, 7, 8, 9, and then again on 1, 2, 3, 4.
No, we cannot do binary search. Means you ignore one half and work only on the second half. If you work on both the halves, then it's not binary search. Then it's not a log n algorithm. If you do, if you suppose I give you a tree problem.
I got your point.
Okay. Yes, Nikhil, you saying something?
Can we like keep on splitting the array and doing binary search on those individuals? I'm not sure if it will work.
Tell me, I didn't get your point, so tell me the code. What code you write? I mean, hint I have given is, you have to do binary kind of search approach only, and you have your middle element is equals to start plus end by 2, and you jump onto the middle element, and you see this is not the element we are trying to find. What do you do after that? If A of mid equal to element which you're finding, then return mid. Else, what will you do?
We'll check A of mid is less than of A of start.
If A of mid is less than A of
Start.
start, then
We can check whether the element is lies between that start and mid element. If it's not lies between this, and we can
no,
ignore the left side
tell,
array.
tell me the code a little bit. So do you have this? Just a second. You have find element. Yes. You have start, you have end, you have array A. Yeah. What will be the code here? Tell me. Else if, what will you do? A of mid is less than A of start, then what? Anyone? What is the else condition? Think about the else condition. Meanwhile, I'll try to write the simple binary search for you right now. Okay. So now I've written my binary set for you. Now you have to tell me how will you change the binary set, tweak the binary set a little bit to solve here. What will you check? So this is the rotated sort array. You landed into the middle element. Try to think. So the you landed on 9. Okay, what we are doing is we are trying to search 4. Will you landed on 9, and you check a of mid, which is 9. It's not 4. So where will you go? Will you go on the left side or will you go on the right side? And how will you decide that? Nikhil.
Yes, Praveen, I'm just thinking one sec.
In else if condition, we can check two conditions here. Like A of mid is less than of element.
A of mid is
less than of element, and A of start is greater than of element.
A of start is
greater than of element.
Okay. So what is impeding is if A of mid, is it less than the element, which is
Correct.
not here, is a more, and A of start is more than element. Then what? Then where do you go? On what side of the array? Right side or left side? Okay, so if you can see, I've drawn something. So this is like our array is sorted but rotated. This is what it means. If you see the graph kind of view, so your number is 4, 5, 6. Can you see the pointer also moving with here?
Yes, yes.
Yeah. So I'm saying is, suppose this is 5, 6, 7, 8, 9, and then the value suddenly. Okay, no, this is wrong graph. Sorry, this is wrong graph. Five, 6, 7, 8, 9, and suddenly 1, 2, 3, 4. This is one kind of. This is one kind of. It can be, or it can be other one. Key suppose 5, 6, 7, 8, 9. Then suddenly it become 1, and then it is longer part. One, 2, 3, 4, 5, 12. Suppose 12. This is 1, 2. This is 8. This is 9. This is 12. What I'm trying to give you a hint. So if you see the first, this is first possibility, and this is second possibility. What do I mean possibility here is either the point of inflection, I'm calling this point of inflection, the point of sudden change is on the right side, or the point of sudden change on the left side. That is, there are two possibilities. So this is not a simple binary search, because we cannot decide by simply checking if the value of the current. Suppose a of mid is here. Suppose a of mid is here, and this is a, and we're trying to find 4. Okay, I'm taking this example. 1, 2, 3, 4 is here. 5, 6, 7, 8, 9, 10, 11, 12 is here. And suppose I'm trying to find 4. Okay, I'm trying to find 4, and I cannot simply say, okay, this value is suppose 8, and a of mid is 8, and this is bigger. I cannot say 4 will be on the left side. Okay, I cannot guarantee, because in simple binary search we could guarantee, yeah, 4 will be on the left side. Let's go here. But a simple very example case is 4 might not be here. So I cannot say, should I go recursively on this side, or should I go recursively on this side? Okay. Do you get this? Do you get this, Suganya, Nikhil, Santosh?
Yes, Praveen.
Yes.
Okay.
So basically, what we can do is, like, we can find out where that point is. We are
Yes.
rotating, and
Yes.
accordingly where that point is rotating, go in that array and then do the search. So split it and sub arrays, you mean, like that? Okay.
Yeah, almost you're close to that point. So we need to be aware where this point of inflection is, where this point of sudden change is. We need to be aware of that. So let's first try to find that only. Okay, let's first try to find that only. Forget about the finding element. Just okay, how will you? So my next part of the question is, okay, before I delete this, let me just tell you what this was about. Second case. So second case would have been the moment the point of where I landed. The point where I landed is bigger. Okay, I mean the point where I landed. I mean the point of inflection lies on the left side. This we have to decide. I'm just trying to the two cases the point of inflection. I'm simply that we have to find that thing only. Where is the point of inflection? Where is the point of change? That's the point we have to find, and that point might be on the right. That point might be on the left. That is what we have to do. First, we have to find that. Once we find that, then only we can find our element. Okay. So I'm deleting this now. Coming back to the code. Yeah. So the question has been changed now. We are simply given an array A which is sorted and rotated. Find the point of rotation. Find point of rotation. Okay. Can someone tell me the code for this? This is simple. How will you find the point of rotation? Find the point of rotation in an array A no one. This is bad. If you're not trying to think, this is wrong. So what we have to do is you have to tell me what is the point of rotation. So this is 5, 6, 7, 8, 9, and then suddenly 1. So what is this index? Tell me. So answer of this would be, the output of this would be 1, 2, 3, 4, 5. So this is the 5. So this is the point of rotation. And you tell, this is what you have to do. How will you find this? Suppose in this case, the point of rotation is 3.
If we find the minimum element from the array, we can get the point of rotation, the index position.
Find the minimum element. Okay, that will also give, yes. How will you find that? That's a simple question, yes.
As I said earlier, first we'll find the mid element.
Can we try to do this like now in terms of code? Just a second. In this case, the point of rotation is 0. Yes, tell me what code should I write? So let me write some code for you. Start plus n by 2. Yes, what we'll do now? If
mid, A of mid.
A of mid
is less than of A of mid plus 1.
Mid plus 1. Okay. Then return.
Then we can return mid plus 1.
Mid plus 1.
Plus 1.
Else.
Yeah. Else. A of mid greater than of A of mid minus 1.
Else if A of mid is greater than
A of mid minus 1.
A of mid minus 1. Then
return mid minus 1.
Return mid minus 1. Others people, keep your brain open. I'll ask questions. Will this work or not? All those things. Return. Else, anything else or done?
Hey Praveen.
Yes.
We are trying to find the smallest element here, right?
Either the smallest element or the point of rotation. Almost same thing for me. Yes.
Okay.
Not getting any thought further.
Okay. Okay. Let me then help you in thinking. So as I showed you the figure, the previous two cases, either this is not special thing. Either the point of rotation might be on the right side, or the point of rotation will be on the left side. Okay. Or it can be, or that point can be the point of rotation. So how will you decide whether that is the point of rotation or not? So to if we see this 9, 8, 9, 1, 9 is the point of rotation. Okay. So what is the special thing about this 8, 9, 1?
Praveen, we can do. Yeah, we can do this.
Just a second. What is the special thing about 8, 9, 1, which is not there in 6, 7, 8, and which is not there in 2, 3, 4? What is the special thing about these 8 and 1? Okay, just try to think now.
The difference.
Yes. Tell me now. What is the special thing about this thing which is not there in these other numbers? In terms of, so suppose this is A of mid. Okay. Suppose this is A of mid. So what will the code be to check? If A of mid, which is 9 here, is more than A of mid minus 1, okay, is more than A of mid minus 1, and, sorry, A of mid minus 1, and A of mid is still more than, is also more than mid plus 1 as well, mid plus 1 as well. So 9 is more than 8 and 9 is more than 1. In all the other cases, the middle element is, if it is bigger than left side, then it is less than the next element. Similarly here, so since this is sorted, the element will be either increasing order, or either it will be like bigger than both sides, or it can be bigger than 1 or less than 1. Okay, so this is the difference. The moment you find this, you know this is the point of rotation. So simple thing. I have written the code for you. So the way to do this is obviously you have to think smart, but otherwise not able to think. Try to. I mean, you can easily see. Yeah, my 9 is my point of rotation. So what is the special thing about this 9? If I check, if I landed at the middle point, I see the left thing is smaller, right thing is greater, and there is no other position. This is special point is there. This is the speciality of the point of rotation, and that's what I've just written it. So point of rotation, if A of mid is greater than the left side and also greater than the right side, this means this is the point of rotation. Otherwise, if this is not the point of rotation, either it will be on the left side of the rotation or the right side of the rotation. Depending upon that, we have to go on that side. So we have to call recursively again. And now this is another point to check. How can I decide whether to go on the left side or to go on the right side? Someone will have to tell me. What conditions should I write here? Nikhil, you have anything?
Praveen, I was just saying that, you can. So you said like, what is the difference between those three subsets of that array?
Yes.
So yeah. So in all whenever there is no point of rotation, the point of change is when the difference is greater than a particular value. Like for in this case, it is 1. So in all the sorted array, the difference is always 1. While in the unsorted part, where the point is changing, it is greater than 1.
Yes, correct. You're correct. So that is also one way. So if the difference of the consecutive element, the next element or the previous element, if difference is 1, then this is not a point of rotation. If this is not 1, then it is the point of rotation. You're correct. But let me think.
But not for all elements, right?
Not for?
Means it is not valid. Like we have 7, 8, 9, 1, 2, 3, 4, 5, 6. Here 9 minus 1 is greater than 1, but again 3 minus 4 is minus 1. So how will you check in this class?
Take modulus. Absolute value.
Okay.
So his point is just check the difference. So you landed in the middle element, check the difference with the previous element, check the difference with the next element. If the difference is 1, okay, I'm not saying if it mid minus 1 or like absolute value, simply absolute value. If that difference is 1, if the mod is 1, then this means it is one bigger than the previous element and one smaller than the next element. This means this is not a point of rotation. So for it to be point of rotation, either of the difference, either the difference with the previous number or difference with the next number, either of them has to be different from one. If that is the case, then that is the point of rotation. Same thing. And I have written almost same thing in other way. Okay. So you have to tell me what this else if condition will be, so that
in this case we have to ignore the left side array and we have to take it the right side array.
I didn't get. So I want this condition. So what this condition should be? What this condition should be for me to find the rotation on the left side of the array? Please draft this condition. Think logically and give me this condition. I want to go on the left side. What should this condition should be? Otherwise, I'll go on the right side. This is this. No, no one. Okay. I have given this one. Try to think like with this case, with this example. I'll give one more minute, and I'm trying to give one more, write one more example. But try to think with this example. Okay. Try to think with this example. What will you check? You are right on the middle element, and you have to decide whether to go on the right or left. How will you decide? Give more pressure, and then I'll give. Try hard.
Praveen, you'll go on the left side if only the element on the left side is less than the middle element, right?
Tell me this. Tell me this. Tell me this code. What code should I write? What?
Like yeah. If A of mid is less than.
If mid is less than.
If A of one second. A of mid is less than. sorry, if A of mid is greater than A of mid minus 1.
A of mid is greater than A of mid minus 1.
A of mid minus 1. And one sec.
See, I'll give you one more clue or hint or suggestion. Do not just compare with the next and previous element. You cannot decide with just comparing with the next and previous element. You have to compare with the start and end of the array. Okay. Don't just compare with the next one, because by just comparing with the next and previous element, you can just decide whether it is point of rotation or not. To decide to decide whether to go on the left side of the arrow, right, or you have to check with the compare with the end of the elements, like start of the element, start of the array, and end of the array also. Okay, think. Or okay, so let me now help you. In this question, in this example, the point of rotation is on the right side. Okay, and the below example, the point of rotation is on the left side. So, what is the special thing about this case? In this case, when we are on the 6, the point of rotation is on the right side. We see what we can see is the left value is smaller, and the right and so start element is smaller, and the end element is also smaller. Do you see this? The A of mid is bigger than A of start, is also bigger than A of end. In this case, A of mid is smaller than A of start and is also smaller than A of end. So I'm comparing A of mid.
Okay.
If it is bigger than, if it's greater than A of start, and A of mid is greater than A of end, in that case, we'll go on the right side. Otherwise, on left side. Will this work? Do you see what I did?
Yes,
I cannot just rely on the next and previous element, because by just comparing with the next, it can be both sides. So by just comparing, so in this case, suppose I do 6, 7, 8. 6, 7, 8 and 1, 2, 3 looks exactly same. Next element will be bigger and previous element will be smaller. So I just cannot rely on the next element and the previous element. I'll have to check with something else. So what is something else? This is compared with the start of the array and the end of the array. Now, as I will try to draw the diagram, I'll try to draw the diagram once again. Where is the annotate? For you to, sorry. So, what I was trying to draw was this, and then suddenly it will be very low, and it will be something below this. Okay, so यहाँ पे क्या, if you see this is 5, 6, 7, 8, 9, 10, 11, 12, and then 1, 2, 3, 4, 5. Suppose this is 4 and this is 5. Okay, this is 5 and this is 12. This is 1 less than 5, which is 4, and this is 1. So I know if I'm landing over here somewhere in the middle, suppose here somewhere in the middle, here this is middle, and now I have to decide whether to go on the left side or the right side. This value will be bigger than the start as well as the end. This will be bigger than this and this way in this case. Okay, so that's why we'll go on the right side of the array. And suppose the middle was this. Suppose the middle was this. Okay, suppose the middle element was this. In this case, what is this? The end of the array and the start of the array, both of them are bigger than me. In that case, if both of them are bigger than me, in that case, the point of rotation will be on the left side of this mid. Do you get this? तो हमारे पास 3 cases हैं. या तो we land here only on the point of rotation, or we land on the left side or on the right side. Okay, if we land on the left side, we'll compare with the start of the array and end of the array. If this value is bigger than the start of the array and end of the array, this means this is the point of rotation on the left side. If we land on this side, and in that case, what will happen is the start of the array and the end of the array will be bigger than me. In this case, both of them are bigger than me, mid element. Hence, the point of rotation on the left side. So, Naya?
Yeah.
All of, okay, got it?
Yes, yes.
Okay, I'll start with the stacks now. I'll give you one question. Let's write the question now only. Okay, I'll write the question now only. So the question was, in a 2D array, rotate, this is a common question, rotate a 2D array by 90 degree. Understand what is 2D array and 90 degree? So we have an array, 2D array, 1, 2, 3, 4, 5. This should become no, there's some problem. Wait. Yes, correct. Okay. This is rotated. Yes, it is rotated. And by 90 degree, yes, by 90 degree also. So you have to, given an array of n by n, you have to rotate by 90 degree. This is a question you have to do at it. We won't do it right now. We'll do it later. Okay. Try solving this. Rotate a 2D array by 90 degree. What we'll learn from this is this writing code for 2D array. So it's not about very smart brain every time. Sometimes it's just about writing code. It's just about writing a of mid is greater than a of mid plus 1. That's those kind of things. If you should be able to write those simple lines. Even after I told you everything, you should be able to write those things. And this question is about that thing only. This is not a very tough question. You know what to do. You just have to be able to write those loops, write those simple a of j equal to a of k or whatever, a of j equal to j plus 1. Those things simple. You have to learn how to write those things. Okay?
Okay.
Shall we move ahead?
Yeah.
Okay.
Yeah.
Okay. So now we'll learn about the stacks. So we have done few questions without much of theory in our array, in our string, and in our Boolean. We didn't go through a lot of theory. Here we'll learn some theory and then we'll take some questions. Okay. So I'm sure you must have heard these words earlier. If not, we'll repeat. But I would expect you that you have heard this stacks somewhere, and what is the special thing about the stacks. Now we learn where to use stack and how to use everything. So what is stack is? So most of all these data structure which you read is all of them are data abstract data types, ADTs. We'll use the term ADTs. Okay. So these are all data structures, and what we'll do is, the way we will try to learn is about the data structure. We'll implement few methods. We'll try to do the implementation. We'll try in Java implementation. We can do in other languages as well. We'll try to implement few of the methods. We should be aware of all the inbuilt methods of data structure. So stack has the methods push, pop, remove, push, pop, and top. Okay. So these methods we should be able to understand how these methods would have been implemented. I mean, no one will going to ask you, but if I tell you these things, you will not forget these things for in your life. Like how was this implemented? So you should be aware how are these methods implemented originally, and also you should be aware of the time complexities of these methods, because whenever we use these data structures while solving our problems, the interview questions, we should be able to calculate the time complexity, because and that will depend on your data structure only, and the methods of data structure. So suppose I tell you how much time does it take to insert an element into array, you should be aware, okay, inserting an element in between an array will take order of n. Similarly, delete element. Similarly, find element. All these things you should be aware beforehand. And array was a simple case because we use that a lot in our day-to-day life, but stacks and these things we do not use a lot, so we might not be aware. Let's go ahead with the slide. So we'll try to write some these access methods, access functions, and special functions like sort and all those also we'll try to implement. So these are few simple methods we should have in our any data structure. How to create a new data structure, like is that difficult thing or not? I mean, we will not be doing this every time, but still how to create a new stack, or like how to insert an element into our stack, how to delete an element from the stack, how to check if it is, find if that present or not, or present at what place. These are few methods we will always try to implement in all the data structures. Why we will implement this? Just to be aware how it is implemented. I mean, if someone asks, you should be aware. And plus, we'll also compute the time complexity of these operations, so that whenever we use these, we are aware of these. Okay, let's go ahead. So we'll do about the same thing for our queue. We'll do same thing with the doubly ended queue. We'll do same thing for linked list. Everything. We might go a little faster in the rest of the data structures. Stacks will go deeper. I mean, we'll go slow and try to explain everything. Not deeper, but slow. So what is this stack? So stack, you all know, is LIFO. The last one comes is the first one to come out of the stack. So the way we place the elements, the way we place the data inside the stack is you keep on inserting on top of the old element, and then if you want to take out the topmost element is the last one which went in, and hence this is last in, but first to get out, first to come out. That's what LIFO. This is LIFO principle. You must have heard this. And few operations which we perform, we have named them as push and pop. Push is like inserting an element, and pop is like removing the topmost element. And then we have top. Top is just checking the topmost element. A simple analogy in our real life case is like dispenser, where or the plates in a party where like plates are kept on one on top of each other. And we bring a plate, we keep it at the top, we keep it we put the new plate on the top of the old plates, and when we want to just take a plate, we take the topmost plate. That's a real life analogy. So we will be implementing new push, pop, and top. And then we have few things also. We'll have size method, is empty method. So if you all Java users or Ruby users, whenever you use a array or something, you always try to array.size, array.isEmpty, array.insert, array or like hash dot hash key, hash dot get, hash dot put. So these methods are already implemented. All these methods we should be able to understand how would that be happen implemented internally. We'll not go very deep because no one asked these questions straightforward, but we'll try to cover as much as we can for our understanding. Okay, so this is a simple interface for stack, which we have just tried to write what all we'll be implementing. We'll be implementing size, we'll be implementing isEmpty method, we'll be implementing top method, we'll be implementing push method, push an element, we'll be implementing pop method, and all those things. Okay, with handling the exceptions. While implementing these few methods, we might get some exceptions. We'll be raising some exceptions as well. We'll try to implement as much as better way as possible. So what exceptions are, all those things which has been explained. We'll not go again deeper into this. We'll just jump to our implementation. So there are few questions sometimes which will be asked to you is like, implement a data structure A using some other data structure B. Okay, so do you get what I'm trying to say? So there are few questions you will be asked in interview sometimes. Not frequently, this is not asked. This is asked sometimes only. I've seen this asked in my college time a little bit. So what the question is like, use a linked list to implement a stack, or use a stack to implement a linked list, or use array and implement stack. So what does this mean? This means I have to use all the properties of one data structure which has already been given. So suppose if I have been given a linked list, I should be able to do next, all those operations are given to me. using those operations, I have to implement my push, pop, top. So that's what it means. Implement one data structure using other data structure. And we'll do this currently. One thing is implement our stack using array, because what we know is array only. Till now we know nothing, but we know arrays. Okay, we know how to do insertion. What we know the operations we can do in the array. That's why we'll use this stack. We'll use array to implement our stack. Everyone with me till now? There's no big thing I've taught till now. Okay?
Yeah.
Yeah. So let's start with this. Yeah. Anything, Santosh? Santosh, anything you have to ask?
No, nothing. Continue.
Okay, let's go ahead. So create a stack using an array, and what we want to understand is, okay, we have an array of size n. So we'll try to implement a stack of size n using an array of size n only. So we are trying to do is implement an array. The name we are given is array stack, and we have to implement this stack only. Okay. So what we do is first initialize with a capacity. This is simple capacity. We'll not be much worried about normally. This is very huge, so we don't care about this a lot. But we still have some capacity, and we have taken one instance variable int n, which is the which can go maximum till this capacity only, and then we have this array. This is what we have used. Okay, this is the internal usage of the array. This array we are using to implement our stack. This S. So we'll always keep in mind. Okay, we have our S. What to do with the S? To handle the elements, to delete element, we'll delete from this S only. We'll insert it in this S only. But to an external user, it will feel like he's just doing everything in on the stack, but internally it will go into the array only. Okay. So we have this array stack, and we are initializing with the capacity and all those things. Now let's come to the main thing. Simple methods we'll implement first, then we'll implement the important things. So suppose we have, I'll also share my, so can you see my desktop, or can you see only the slides? Can you see this desktop as well?
No.
Okay, let me just share the desktop completely. Okay. So we are implementing stack using our array. So we have an array, suppose S, which is the name we have given it S. This is an array already initialized with nothing is there, and we want to implement methods. Initially, lots of elements are there, methods are there. The pop, push, top. These are important ones, and then simple size and is empty. Okay, these are simple methods also we can implement. And what we already have is a kind of n, which is equal to the capacity, the total size, the total capacity, which is 201, whatever initially you can initialize with, whatever. Let's go ahead and see the slide. Yeah. So how will you implement your method? Where is the method size? T plus. So one more thing we have initialized is T. I'm writing pseudocode, initialize. Sleepy people?
No.
Okay.
No.
Okay. I can hear someone. Okay. So what I'm doing is, so we have this S, we have this capital, and we have this T initially. Now using these three things only, we'll implement everything. Okay. We have an empty array, we have an index T. Okay. Right now we have no elements. So initially it will be T equal to -1. We have no elements in the array, and which is equal to, we have no elements in our stack. Hence our T is equal to -1. Now using these three things, we'll be able to implement everything. Let's go back to our slide. So first method we have to implement is size. What is the size of the current? What is the current size of the stack? So first thing we are implementing is size. What is the size of the stack? So that by implementing this, we can. So whenever we use the stack, what we'll be able to do? We'll be able to call my stack dot size when that's what we want to call, and we want it to return the size of the stack. What is the current size? This is what we want to achieve. These two things, okay? And how can this is what by to achieve this, how it has been implemented, we should know. So size, how it would have been element. It will not do anything, just return t plus 1. That's it. Simple. जहाँ पे index, जहाँ तक हमारा index है, that is the size. So if t is equal to -1, this means -1 plus 1 0. Currently the size is 0 only. The moment suppose we insert element in this S, suppose we have few elements inserted. Suppose we have this element. In that case, size will be t. Still, size will be how much? T. Suppose if t will be 4 at this point of time when S is this, t would have been this. Then size is equal to t plus 1. Size is equal to 5. Simple. Okay. Very simple implementation. There is no special thing over here. How will you implement is empty? Anyone? How will you implement is empty? Very simple. Not a tough thing. Tell me. How will you implement is empty?
We have to check if if there is any first element or not.
Yeah, so simple. Return if t equal to -1, or just return this. Will this work?
Then we can return that it is empty.
Yeah. So if t, I mean this is a simple line, the same thing only. If t equal to -1, true, otherwise false. Okay.
Yes.
Same thing has been written here. If t is less than 0. Okay. If t is less than, same thing. I'm not doing anything else. Okay. If t is less than equal to 0, less than 0, this means this is empty. So t, what is t? T is the index of the last element. That's what t is. If you want to understand what t is the index of the topmost element. In case of there is no element, t will be -1. If t is less than 0, then this is. Now comes the main methods. Let's talk about push. So we have capital S, we have small t. Using these two things, what will you do when a new element comes? Okay. So what do you want to achieve? Again, I'm writing it as a user as well as implementer. So as a user, I want to do is my stack dot push element. Suppose I get 5. I want to do this. I want to call this as a user. I want to call this. What should I do as an implementer of the method? What will we do? Can someone tell me what will we do?
Insert at array size plus 1.
Simple thing. Awesome. So what is the array? Array is the S. And where to insert that? Just insert it at t plus 1. T plus 1 equal to new element. The element which just came. And then also increase this t. Okay.
Yes.
That's it. Simple implementation. ठीक है? Is this okay? Everyone?
Yes.
Simple
Yes.
implementation. And we're not doing much. We can do a little bit more thing if checking if our t is equal to n capacity. If it's equal to capacity, we can throw exception. All those things can be there, but I'm not doing it right now. This is not important thing. Otherwise, just implement. Just insert. Okay. I'm writing pseudocode. If it is already full, throw this exception. Otherwise, just insert at th index and increase t. That's it. Nothing else. Now someone do it fast. We'll do fast. Pop element. Before pop, just tell me top. What is top? What does top means? What is the topmost element right now?
Return yes of t plus plus.
Got. Good. Nice. Nothing. Just return this. Return of t. That's it. Someone. No, this is not pop. This is top. Pop is removing as well. Someone tell me pop. Pop. Someone tell me pop.
We can store the variable in n+1 1th position and then keep on popping them.
No, pop. What does pop means is just remove the topmost element. That's it. Pop means remove the topmost element.
Okay.
So we have the topmost element at TH index. Just make it
Null.
And before making it null, store it somewhere else so that we can return also. Because pop is not just removing but also returning. So return. And one more thing is missing. Who can tell what is missing? One more thing is missing. We have to do one more thing.
T minus minus.
Awesome. Done. Simple implementation. We've implemented all the 5 awesome methods. The insert is there. This is the insert is, which we call post. This is the delete, which is pop, and this is find, which is top. I mean, we might not. It's not find. It's just the topmost element. So finding would be difficult task. All those things, because stack is something we does not support find so easily. My stack. If I tell you, you find some element in the stack. This is not already implemented. You have to do something else. We have to use pop multiple times to implement these things. But these things are already implemented in the stack, push, pop, and top, and you can use this simply. And we have done the implementation ourselves. So now the last thing left is complexity. Let's start with push. What is the time complexity of push?
O of 1.
Great. Now top.
Same.
Top. Pop.
Pop also same.
Okay. These are also same. These are also same. Okay, so that's what the slide would be about. Let's go through the slide once again. So they have implemented size, they have implemented top, throws stack empty exception. If stack is empty, then it's throws exception. Otherwise, return S of T. This is top. We do not do all those edge cases of handling exception, but we simply wanted to understand. Okay, this is pop. What pop does is, again, before it takes out the topmost element, it has to check whether it's empty or not. If it's empty, then instead of pop, we cannot pop. So just throw this error if it is empty and throw the stack is empty. Otherwise, element is equals to st, s of t equal to null, and then t minus minus, and then return the element which we just saw. Okay. So these are few very simple implementation, and time complexity also we have seen. Okay. So we are done with the stack as a theory. There is no bigger thing. We know what a stack is. We know the methods available in a stack. We know the time complexity of each method. We know stack dot push is constant time, stack dot pop is constant time, stack dot top is constant time. We know all these things now. Now we can use this stack. Where to use is one thing we will learn a little bit, and we will do some questions. Let me just. And one more thing is we learned about the implementation using array. Same thing we could have been implemented using something else as well. We'll do one more implementation. Just before that, we'll cover a few more things. A growable array based stack. This is something, if you get by the word. So we initially what we did was we just defined the capacity, and we told, okay, the moment we reach the capacity, we'll throw some exception, stack full exception. Sometimes we would prefer if we had a growable stack. So what happens is the moment it is full, we'll increase the size of the array, and then once we have this array size increased, we can push more elements. As simple as those things. Again, not a very deep thing to learn, not a very big thing to learn. Simple, just think. Sometimes we might be using a growable array-based stack as well. No, we don't have to spend a lot of time here. Tight versus growth, and this is telling us there's more slides on again theory. No one asks these things. These are mostly again to learn about deepen about the stacks. So how do you suppose we want to implement this growable array-based stack? When will you decide when to increase the size of the array? So there can be two strategies. Either we'll a tight strategy or we'll growth strategy, something like that. What happens in these strategies are like we'll decide when to increase the size of the array? Do we increase the size of the array every time the element is full? Or do we increase by only n size, or do we increase by 2n size? Something like that. I'm not covering this. You might, if you're really interested, I'll share a slide. You can read this. You'll understand yourself. If you do not understand, ask me. But my thing, no one has ever touched these points. No one who asked these things. But I'll say, if you want, you can go through yourself. Yes.
Yeah, Praveen, can you share us the slides?
Yeah, I'll do. I'll share.
Okay.
Yeah. But I'll suggest, do not waste a lot of time. If you're not teaching this, it really doesn't make sense. That's why. These things were made sense in the academies, in colleges where we had 5 or 6 months of classes, the courses, and where the questions were exactly what is stack and how do you implement stack. Now the questions are not what is stack and how to implement stack. The questions would be mostly you on the base of usage of stack. No one is going to ask you the implementation of a stack based on array. Okay, that's why I'm not doing this. I'm not wasting this a lot of time here. Going ahead. Okay, so we are done with the stack today. We'll do one more linked list as well, theory part. Okay, I'll not do questions today, because if I start one question, I'll give one question for you before I end the class. But I'll not do questions today because it will take a lot of time to finish. I have the time we have this. We'll do one more linked list. Okay, same thing. It will be easy for you to understand. It won't take much time. But whatever we did in the stack, we'll do same thing in the linked list as well. Okay, just give me 1 minute. Okay, so this slide is about queues and linked list. First, we will talk about queues. Okay, not linked list. Queues. They're a little bit similar, but we'll learn about queues first. The good thing about stack and queues, not a good thing, but very interesting is they are like, sometimes they complementary to each other. Something which can be done using stack cannot be done using queues, and something which can be done using queues cannot be done using stack. So these are complementary a lot of times. Either you use this or you use this, and this also very much goes with the name as well. That was LIFO, last in but the first one out. In this case, this is FIFO, the first in and the first one out. As simple as our real life queues. When the first one who is in the queue will get the ticket first, and the last one who comes will get the ticket first, last. That's what FIFO means. So this is about the queues. We will try to implement our queue as well. Okay, the way we implemented our stack, we'll try to implement queues, and we'll also be knowing what are the methods available in queues. All of you have heard about queues also?
Yes.
So good that I took this queues theory, because I'll try to do the question and we'll decide, okay, why are we using queues and why are we using stack here, and why are they complementary to each other? Okay, we'll compare very, very much queues and stacks. So few terms about the queues: the rear of the queue and the front of the queue. This is in the rear of the queue, we enqueue element, we insert at the rear, at the back, and we dequeue from the front. Dequeue means take it out, remove, delete, front. Okay, so these terms: front, rear, enqueue, dequeue, insert, delete. Okay, these terms we have to be aware of. So we have this kind of a queue where this is the front and this is the rear. So we have the element whenever we dequeue from here, the front. Whenever we enqueue at the end here. Okay. So as I told, the few methods which we'll be implementing about the queue in the queue is enqueue, which is insert, which is similar to the push. I mean, not similar, but which is same as the push thing. This is dequeue. This is same as the pop thing. Dequeue is like remove element, and then front, which is same as the topmost element. We can find the front also. The top of the stack here, it is front. So front, what is the frontmost element? Okay, these three things are there, and obviously those size and is empty will always be there. this also we are trying to implement this also using an array only. Okay, we are trying to implement our queue using array. Same thing. What I did for the stacks, where is this? We should be able to do same thing for our queues. Very important topics. Lots of people use it, and there lots of questions are based on these things. People will ask you, and you should be very much aware of the terms and everything, and the complexities and the benefits of those things. So we are implementing our queue. And the methods we will have to implement is, again, we are using an array S. Let me just slide with our S and the capacity and everything. And MQ, BQ, and then last one is front. Can someone tell me how will you implement? I'm not asking this method, but just telling, is S and T good enough for implementation, or do we need something else?
Front and rear something.
Come again?
Front and rear.
Front and rear is we have to maintain or something. So what you said is we have to maintain the, earlier we just had to maintain the topmost index, but in this case we have to maintain front and rear index as well. Why? Because whenever we delete from the front, that front index also changes. Okay, and when we insert at the back, the back index also changes. The end index also changes. That's why instead of just implementing T, we'll have something like front index F and rear index R. And when we initialize this will be F will be something and R will be something. This will be -1 and this will be -1. Okay.
Mm-hmm.
There is no element, so these are both -1. Is that what they have done? Let's see. Front and rear. Okay. And when you implement this, they have initialized somewhere. They have. Okay, we'll do it ourselves. Okay. So, as Santosh told, we'll have to maintain two indexes in this case, not just one. Two indexes are needed. Someone do it fast and implement using N, S, F, and R. Tell me, what will the code be for is empty?
F is greater than 0.
One person, Sonia.
We have to check the front or rear is 0 or not.
So,
sure whether the front or the rear.
So we initialize with F -1, R -1, and for these to be empty, the check would be something else, not 0, something else. So
Praveen,
let me, yes.
If front is equal to rear, right?
Yes, front equal to rear.
Front equal to rear will return
Empty.
Okay, awesome. This will return. Okay. Okay, got it. Size.
Return F.
Size. Return. Can we do return F or R, or we have to do this?
Just return F, I think.
No. So suppose we initialize with this, we just kept on inside it, we did not remove. Now suppose we remove. How do we remove? We haven't implemented the remove yet, but we removing is like this. This is what removing means.
Mm-hmm.
So what is this? After we removed 1, the F has moved to 1 step ahead and R is still there. So what will the size be? F minus R minus F, not just F. R minus F. Because what is it doing? As I told you, when we insert at the back. So if it will, after insertion, what will this become is 6. And our rear will change. Rear will increase by 1, but front will still be there. If we delete, how do we delete? What this will become this. I'll maintain F and R for you also. F is equals to 0, R equal to 4. In this case, someone mute your volume. There's some noise coming. If it... So, saying every time we insert or delete, whatever we do, we change our F and R. Okay? So, the size is not just F. In this case, F is 0, then F is 1, then still F is 1. Now F is 2. So, the size is not 2. Size is first front index and this index, the difference of these two, R minus F.
Okay.
Got it?
Yeah.
Someone do the implementation for NQ. Fast.
Yes, of rear.
Yeah, tell me.
Yes, of rear equal to element.
NQ, S of rear R equal to element and what else will do?
Increment.
Awesome. Next one, someone do it fast.
Yes, of F minus equal to element.
Why minus?
Sorry, plus.
So first of all, SF equal to null, and then S of F. Sorry, DQ is written also. So return front.
SF will be plus or minus?
You tell me.
We are deleting the value.
Yes, we are making SF equal to null, and we are. So this is F. F is equal to 0 and R equal to 4.
Increment.
We deleted. We are incrementing, na? We are not deleting. We are incrementing. This is becoming null now. Our F has moved here. Okay. Earlier F was here and R was here. This is F into sign. The moment we deleted one element, F has moved by 1 position ahead and R is still there. Okay. So F again incrementing. ठीक है, दिख रहा है?
Yes.
Done. Time complexities.
NQ. 1 for all the conditions.
Order of 1. So same as stack, almost same as stack. So we have done our stack, we have done our queue. Both of them are similar. Both of them are like they have the different methods. NQ, DQ in front, and it has push, pop, and top. But time complexity are all of them are order of 1. And using these, we'll solve lots of more questions. Okay, using these things only, we'll solve a lot of more questions. You have to, your tasks are, first task is, in whatever language you prefer, you have to implement Q yourself. Like whatever I wrote, you have to implement Q in whatever language you want. And I should be able to I should be able to initialize a queue from your code, and then I should be able to do my queue dot enqueue, my queue dot dq, my queue dot front. I should be able to do, and it should work for all the cases. You have to take care of all the edge cases. Will you be able to do?
Yeah.
Okay. And I'm not doing any more questions now. I have to give you a few questions on the stack. One question on the stack. Did I give any question on the stack? No, no?
No.
Okay. So before, and I have given you a question on the rotate 2D array. Rotate 2D array. One question is, I'll give is reverse a string. 3 questions, good enough, more than enough. Try to write code for all of them. I'm interested in that. So these questions are not tough questions. These are not very tricky questions. But thing is, we should be able to write a code, and I want you to practice. Okay? There are no lot of tricks here. The tricks like we'll do something smarter. Those things are not there. Like we'll be doing binary search or something. But this is very simple. Just try to write lots of codes, and we'll try to see this tomorrow or sometime like or during the day as well.
Okay.
So the good thing is we know about queues and stacks very deeply. I mean, there is no theory left for you to solve any problems. What is left is how to use those in places. But theory-wise, if someone asks you, do you know what stack is? Do you know how to implement stack? Do you know you are aware. You know the theory now. Okay.
Yeah.
So was it helpful? Did you think you know something new today about your stack and queue, or this is like
Yes,
not? Okay, awesome.
Yes.
So I just want to similarly we'll do it for all the data structure, not just these two. We'll do it for all. These are very easy ones. The complex ones will be there, and with implementation, the basic methods how they have been implemented. Once you are aware of the basic things, it will help you in thinking a lot. कि मुझे क्या use करना है, कब use करना है. These things will add. You might not see the direct benefit, but if you are aware of these things, you'll see an indirect benefit of decision making. What to use will be very easy from here. Sometimes you think whether I use a stack or array. You know the stack has these benefits, and the stack is already using the benefit of array also. So why should I go for array? Why should I not go for stack? You will be able to draw those conclusions from these implementations. And the most important thing, the time complexities. Okay.
Okay.
Yeah. Any questions?
Praveen, I am having one query.
Yes, Santosh.
If someone asks the question like, can you implement the queue or stack by using another data structure? So whatever we have implemented, this is the same way we have to use, or something we can use some other data structures a better way. So array is the better thing to implement.
No. So you only told the question. Question is कि if someone asks you to how to implement a data structure using some other data structure, so which means the other data structure they will tell you. I didn't tell you use anything. I told you use array only. So that's why you use array. If I told you okay, you implement stack using anything, then you will decide what to use. But in this case, I told you implement stack using array. That's why you use array. If someone tells you can use anything, then you can use anything. But mostly the question would be if asked, which is very rare, but if asked, they will tell you implement data structure A using data structure B. They will always tell you. They will know. There won't be any question like using implement A using anything. That kind of question won't be there. So they will always tell you implement A using B, and in that case, you can use anything of the B. You can use B anyhow. So suppose I give you a question, I can give it now as well. Implement this. I don't expect you to do it in one day. Implement stack using queue or the opposite. This question was asked to me again in my somehow I remember because I couldn't solve that during my school college. I think you also must have been asked these kind of questions in college. So these are they will always tell you. So in this case, you can use anything of the helping array. I am cutting it. Okay. So in the fourth question, the implement stack using queue. You can use q dot front, q dot rear, q dot q dot front, q dot rear, q dot dq, q dot nq. You can use all those things to implement stack dot pop, stack dot push, stack dot top. The opposite thing is here. You can use stack dot pop push top to implement. Use those things to implement your front, rear, and everything.
Okay.
Okay. Yeah.
Inside the queues, and there are other things like circular queues, and also those things will be also get covered, or those things are not.
Again, my point is those are not basic data structures. Those are like modified. It's like rotated array only. That there's a question which we'll be doing. Now that you have reminded me, I'll write this question for you. We'll do it sometime. You can also note it down somewhere. If I don't cover these things, then you can remind me sometime. Okay. So these are questions. I'm not taking those things as theory, basic theory. These are all types of variation of the questions. This is the basic, what I told. So circular queue, if you talk about that as a basic data set, doesn't make a lot of sense to me. This is one of them. What is this? This is special queue where front and rear are linked. That is something that, okay, that's front and rear linked. That's what circular queue is. So the question is, tell if a queue has circle. And then there are other question is, tell if a linked list, we haven't covered this yet, we're not a difficult thing, has a circle. And then question number 8 can be, where is the start of this circle, if the circle is there. Then question can be, what is the size of the circle? These are standard questions. I won't call them a special data structure. Okay? We'll do this kind of questions, but not as theory, but as questions. Okay?
Okay.
Yeah. Anything else, Nikhil, Sukanya?
Yes, okay.
So let me just write tomorrow what we'll do. So what do you want to do tomorrow? One thing which I want to do is, let me tell you, 2 questions on stack. Let me write first and you can add, we can decide. And then 3 questions on stack and you mix. And then this one, we'll discuss this. We'll discuss this solution as well. And then we'll discuss these 2 things, only discuss, no coding for this. That's it. Yeah, that would be, and if time permits, we'll discuss about these 4 things as well. Okay?
Okay.
Anything else you want to cover tomorrow? That will be more than enough, by the way, but yeah.
Praveen, I am having one question I recently faced in one of the interview.
Yes.
The question is like, get the minimum length of the string from the stack in order of one time.
I am not getting this. Get the minimum
length, the minimum length of the string.
Or string
from the stack.
From stack.
In order of one time, means the best complexity. So he specifically mentioned we can get by using order of one time.
That is all right, but minimum length of string from stack. Anyone get the question? What was the question?
The stack having the number of strings.
Stack is having
strings actually, like ABCD.
Okay. Stack contains strings.
Yeah.
These are all inside the stack, and you have to find the minimum length of the string, or length of minimum. What is smallest string. What is it? I don't
Yeah,
get.
smallest string, yes.
Okay. We'll do it tomorrow. Okay. I mean,
Okay.
I can come up with solution now, but let's do it tomorrow. I have to rush now. We'll do it tomorrow.
Yeah, sure.
Others, do you want to try now? So this is nothing but finding the minimum value from a stack. Okay, the length of string is not a big thing. The string is just to deviate you from the main thing. This is like find the minimum element from the stack. Okay, this is nothing but just finding the minimum element in the stack. So what Santosh asked is, given a stack which contains lots of strings, find the length of find the string with the minimum length. What is the length of the smallest string? Is that the question, Santosh?
Yes.
So this is same as we have a stack of elements, integers. Just tell me what is the smallest number. That's it. Same question. Just to deviate a little bit. Okay, there are strings of, and you have to find the smallest string size. This is same as this. Both of them similar. Think you can do it yourself, but you're saying order of one. I don't think it can be done in order one. The question would be something different then. If this is the question, it's impossible to do in order one for sure. So you can just try to go and see the question once again. Same question cannot be done in order one for sure. I'm 100% sure. Okay, we'll do it tomorrow. Try to find the question. We'll do it tomorrow. I have to rush now. Okay.
Sure.
Okay. Awesome.
Okay.
Bye.
Okay. Yeah. Bye.
Bye.